Hi students, today we're going to talk about covalent bonds, learn how to name and write those, which are a lot easier than ionic, as well as talk briefly about alloys. Multiple bonds. Covalent bonds can form either single, double, or triple bonds. When you have single bonds, you might see them written with just one line. A double bond would be 2 lines, and a triple bond would be 3 lines. What happens in a single bond is sharing 2 electrons, a double is sharing 4 electrons, and a triple is sharing 6 electrons. So in this nitrogen, you've got 6 electrons, so that's a triple bond. You also could write nitrogen like this. Here up top would be hydrogen. They're sharing 2 electrons, so that's a single bond. So you could also write hydrogen like this. Fluorine is also a single bond. Here we've got 2 electrons being shared between them, so you could have carbon dioxide. I'm sorry. So you could have carbon dioxide written like this. So that would be a double bond between both the C and the O. Polar versus nonpolar molecules. A polar covalent bond occurs when the sharing of electrons is unequal. What happens is it results in 2 poles or ends. The positive pole is where electrons spend less time, and the negative pole is where electrons spend more time since electrons are negative. In this picture, water is polar. The oxygen actually hogs more of the electrons, and so that's the negative pole, whereas both hydrogens have a positive pole. Nonpolar covalent bond occurs when electrons are shared equally. It doesn't allow for the creation of poles, hence nonpolar. This is a picture of carbon dioxide. Carbon shares the electrons equally with both oxygens, and so it is nonpolar. Diatomic molecules. This will be important for this chapter as well as next chapter, so make sure you remember which atoms are diatomic. They are elements that form a covalent bond with itself. Di just means Latin for 2, and they are found in nature this way. These are always nonpolar covalent, and the elements are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. In nature, hydrogen is not found just as H, it's found as H2, as well as the rest of those. And so to help remember, you can remember Count Brinkelhoff. So Brinkelhoff stands for each of those 7 elements. There's another way also to remember that, and that is looking at the periodic table, and I'll show that to you in class. Now let's talk about naming covalent bonds. Naming covalent bonds, you want to name the first element. Only use a prefix if there's more than one element. Name the second element. Always use a prefix. Their prefixes are in the table on the right, and you need to make sure you know all of those for the test. And for the second element, you always change the ending to "ide." So let's practice. So we've got PBr5. So looking at this periodic table, we've got P, which is phosphorus, and Br, which is bromine. So we've got P, and since P does not have a subscript, you do not need to have a prefix. So P was phosphorus, and Br was bromine, but you need to change the ending to "ide", so that'll be bromide. And it always needs you always have to have a prefix on the second one. So the subscript is 5. So looking at your chart, 5 is penta. So it'll be penta bromide. Let's try the next one. So we have H2O. H is here, that's hydrogen. O is oxygen. The first one has a subscript, so it does need a prefix. It's 2, so 2 is di, so it's going to be dihydrogen. The first one, never you change the ending. It's always going to be just the element. It might have a prefix. Since it has a subscript, it needs a prefix. The second element always needs a prefix. So since there's no subscript, that's just going to be 1. 1 is mono. So it will be mono. And then we need to change the ending to "ide" for oxygen. So it'll be oxide. They don't like to double up the O's, so it would just be oxide like that, monoxide. If you wrote monooxide, I won't dock you. But water, the scientific name for water is dihydrogen monoxide. Now we're going to try writing the formulas. So we've got dinitrogen trisulfide. So we've got dinitrogen and trisulfide. So we've got nitrogen and sulfide. So nitrogen is here, which will be N. Sulfide will be your sulfur, which is S. Looking at the prefixes, we've got di and tri. Di and tri. So di is 2, tri is 3. So di was 2, so nitrogen, which is symbol is N. Then we've got the di that tells us a subscript of 2. Sulfide was S. We've got the tri, that tells you the subscript is 3. The nice thing about covalent compounds is you don't have to cross any charges or anything. You don't cross anything over. The prefix tells you the subscript. Pause and try to do the next one on your own. Now we have carbon tetrachloride. So looking at periodic table, we've got carbon, which is here, and then we had tetrachloride, so that's going to be the chlorine, which is right there. The only prefix we have is tetra, so tetra is here, which is 4. So carbon, which was your C, since it doesn't have a prefix, it means it has no subscript. And then we have chloride, so we got Cl. Tetra was the prefix 4, so it's going to have a 4 subscript. Now we just need to talk about alloys. Alloys are a mixture of 2 or more elements, at least one of which is a metal. They do have properties of metals, and some common alloys are bronze, which is copper and tin, brass is copper and zinc, and steel is carbon and iron. That is it for today's note.